Okay, so this is a typical normal distribution question. This time they've given us raw data. Okay, so raw data literally means they've sort of given us the numbers and we have to do something with them. So we need to use our calculators. So we need to enter these into the statistics function and work out what the answers to these questions are. Right, now if you do that, we will find that the first one, I, is 0.516. We'll find that I is 0.613, and we'll find that I is equal to 0.968. Okay, so that's 3 marks, and that's our first thing, just using our calculators. Take care of. Right, now they tell us the data has a mean of 11.6 and a standard deviation of 2.6. We need to show our results from part A to decide whether the data can be modeled using random variable t. So remember, t is our discrete random variable, modelled roughly as a normal with the mean we've just been given and the standard deviation we've just been given. So now, let's use this diagram of a bell curve. So the mean is 11.6, so that means that this is 11.6. Okay, now remember, these are our standard deviations. So they've told us the standard deviation is 2.6. So this must be 14.2. Add another 2.6. This must be 16.8. Going the other way, if that's 11.6, this must be 9. And then take away another 2.6. This is 6.4. Now look at these. For I, it was less than 11.6. Well, that's the mean. And for a normal, the probability of t being less than the mean is 50%, okay, or 0.5. So that's pretty close because we got 0.516. Okay, now next one for II, this was between 9 and 14.2. 9 and 14.2, this is minus 1 standard deviation, and this is plus 1 standard deviation. And remember the 3 numbers are supposed to remember, this should be 68%. So the probability that t is between mu minus 1 standard deviation and mu plus 1 standard deviation should be 0.68. And we've got 6.3 again, pretty close. And then if we look at 6.4, we look at III, that's 6.5 to 16.8. Well, that's minus 2 standard deviations, and that's plus 2 standard deviations to 16.8. So again, it's slightly different. Our error is slightly bigger, okay, but we should know with a normal, the probability of t being between mu minus 2 standard deviations and mu plus 2 standard deviations is 95%, or 0.95. And we've got 968 because it is a slightly bigger area because 6.5, 6.4. Right, okay. Again, they are pretty close. So on the back of that, we can say that as it's close to what expected, the model is suitable. Okay, now remember, this is a written question. We've justified our answer, we've shown why, and now we've written a sentence that explains, and it uses the key words, okay? It's what we expected to happen before we did the experiment, okay? And the model is suitable. So we've talked about the model, we said the model is suitable. We talked about what we expected to happen, which are these things here. And then we've looked at the actual results from the experiment. Okay, so remember that it isn't so much of a perfect answer, but the keywords that they're looking for in your answer.